Welcome to Lecture L2C of Computer Programming Fundamentals. Computer Programming Languages, the 1950s. The 1950s introduced the era of general-purpose computer programming languages. This was a major turning point in the evolution of computer programming languages. Thus, the general-purpose computer model created by John von Neumann in 1945 could finally reach fruition, namely a general-purpose computer programming language driving a general-purpose machine to provide a special-purpose application programming solution. The 1950s ushered in a decade of prolific computer programming languages development. Development of general-purpose computer programming languages that drove John von Neumann's general-purpose computer model. Many of these general-purpose computer programming languages, although some 60 years old, are still used today. Starting with assembly computer programming language, classified as a low-level computer programming language because the source code was directed at the machine level. A computer programming language requiring a high level of computer programming expertise, and ending with the RPG computer programming language, where RPG is short for Report Programming Generator, a computer programming language requiring very little computer programming expertise. Interestingly enough, the common characteristic of all these computer programming languages of this period is that they were all general-purpose computer programming languages. The assembly computer programming language is a low-level computer programming language used to program a wide range of computer programmable devices, where each computer programming statement corresponds to a single machine code instruction. Each assembly computer programming language is specific to a particular computer architecture. For example, I used assembly language specific to the IBM 360 series of mainframe computers. Contrast this to most high-level programming languages, which are generally portable across multiple computers. Assembly computer programming language instructions are converted into executable machine code by a utility program referred to as an assembler. The conversion process is referred to as assembly or assembling the code. The assembly computer programming language uses mnemonics to represent each low-level machine operation or opcode. Some opcodes require one or more operands as part of the computer programming language instruction. Most assembly computer programming languages take labels and symbols as operands to represent addresses and constants. The slide shows an example of assembly computer programming language source code with the machine object code generated by the source code. Autocode is a generic term for a family of computer programming languages. Autocode was developed to program a series of digital computers. As such, different autocodes were developed for different computers. The first autocode and its compiler were developed by Alik Glani in 1952 for the Mark I computer at the University of Manchester in the UK. The first autocode is considered by some to be the first compiled computer programming language. The second autocode was developed for the Mark I computer by R.A. Brooker in 1954 and was called the Mark I autocode. Fortran is a general-purpose programming language that is especially suited to numeric computation and scientific computing. Fortran was originally developed by John Backus at IBM's campus in San Jose, California in 1957. Fortran came to dominate as a scientific computer programming language As such, Fortran early on became established as a scientific computer programming language. A scientific computer programming language used for developing application solutions that are computationally intensive. In fact, I used Fortran in the late 1960s to solve mathematical models that were part of my Operations Research MBA program. The IBM 704 was the original targeted computer in 1957 for John Backus's original version of the Fortran computer programming language. Today, Fortran is used for high-performance computing. For example, the Blue Genie P supercomputer at the Argonne National Laboratory. Fortran is also used for computer programs that benchmark and rank the world's fastest supercomputers. Fortran was initially derived from the IBM Mathematical Formula Translating System. Since Fortran's birth in 1957, each progressive version of Fortran has added extensions while retaining compatibility with previous versions. As such, Fortran, some 60 years later, is still thriving to support scientific computer programming language-based application solutions. Lisp is a member of a family of computer programming languages. Lisp was originally specified in 1958. Today, Lisp is considered the second oldest high-level computer programming language, which is still in widespread use. Only Fortran is older, given by only 1 year. Like Fortran, Lisp has changed a great deal since its early days. As such, a number of Lisp dialects have been developed since 1958 that have sustained the Lisp computer programming language over the last 60 years. Lisp was originally created as a practical mathematical notation for computer programs. Thus, Lisp was influenced by the notation of Alonzo Church's lambda calculus. As such, Lisp quickly became the favored computer programming language for artificial intelligence application solutions. As one of the earliest computer programming languages, Lisp pioneered many ideas in computer science, specifically tree data structures, automatic storage management, dynamic data typing, and the self-hosting compiler. The name Lisp is derived from Lisp processing. For example, linked lists are one of Lisp's major data structures. In fact, Lisp source code is itself made up of lists. As a result, Lisp programs can manipulate source code as a data structure. This gives rise to macro systems that allow computer programmers to create a new syntax or even a new domain-specific languages embedded in Lisp. Lisp was invented by John McCarthy in 1958, while McCarthy was at the Massachusetts Institute of Technology. Lisp was first implemented by Steve Russell on an IBM 704 computer. Russell realized that Lisp could be implemented in machine code. The result was a working Lisp interpreter, which could be used to run Lisp programs. This led to the first complete Lisp compiler. The compiler was written in Lisp and was implemented in 1962 by Tim Hart and Mike Levin at MIT. The Lisp compiler introduced the Lisp model of incremental compilation. Incremental compilation is a technique allowing compiled and interpreted functions to be intermixed freely. Lisp was found to be a difficult computer programming language to implement with the compiler techniques in stock computers of the day. As such, Daniel Edwards, an MIT graduate student, made substantial improvements to the Lisp compiler. This made it practical to run Lisp on general-purpose computers, but efficiency was still a major problem. This led to the creation of Lisp machines. Lisp machines were dedicated computers for running Lisp computer programs. However, advances in both computer hardware and compiler technology soon eliminated the need for Lisp machines. These events led to an effort to unify the work on new Lisp dialects. The unification resulted in the development and adoption of Common Lisp. As a result, the American National Standards Institute published the Common Lisp Standard. Thus today, a common dialect of the Lisp computer programming language is available, a common Lisp that runs on a variety of general-purpose computers. ALGOL is short for algorithmic language. ALGOL is a family of imperative computer programming languages. ALGOL was originally developed in 1958. ALGOL greatly influenced many other computer programming languages. ALGOL was recognized by the Association of Computer Manufacturers as the computer programming language that best met the requirement for supporting algorithm processing, where algorithm processing is an effective method expressed as a finite list of well-defined instructions for calculating a function. As such, the processing of algorithms became the cornerstone of computer programming languages, a cornerstone that led to dramatic advances in computer science. Thus, dramatic advances in computer science were first fostered by the ALGOL computer programming language. As such, ALGOL was arguably the greatest contributor for advancing computer science among the other three high-level computer programming languages of the same era, namely Fortran, Lisp, and COBOL. For example, ALGOL was designed to avoid some of the perceived problems with Fortran. ALGOL also gave rise to many other computer programming languages, including BCPL, B, Pascal, Simula, and C. For example, ALGOL introduced code blocks, including the begin and end pairs of braces for delimiting code blocks. Also, ALGOL was the first computer programming language that implemented nested function definitions. Moreover, it was the first computer programming language which gave serious attention to the formal computer programming language definition, namely the Backus-Naur form, a principal notation for computer programming language design. By the end of 1958, the ZMMD group had built a working ALGOL 58 compiler for the Z22 computer. Friedrich Bauer is recognized as one of the early developers of ALGOL 58, where ZMMD was an abbreviation for Zurich, München, Mainz, Darmstadt. These were the cities in Germany where ALGOL 58 and the Z22 target machine development took place. ALGOL 58 saw some implementation effort at IBM, but the effort was in competition with Fortran. As such, ALGOL development by IBM was soon abandoned. ALGOL 58 was also implemented at Dartmouth College on an LGP30 computer, but that implementation soon evolved into ALGOL 60. An implementation for the Burroughs 220 called B-ALGOL evolved along its own lines as well, but retained much of ALGOL 58's original character. I personally used B-ALGOL myself in the early 1970s on a Burroughs B5500 at the State of Michigan Highway Department. The B5500 operating system was written in B-ALGOL. The B5500 was one of the first computers featuring virtual memory. Summing it all up, ALGOL 58's primary contribution set the stage for the computer programming languages to follow, namely those computer programming languages that further advanced the discipline of computer science. COBOL is one of the oldest computer programming languages, still prevalent today. COBOL is the acronym for Common Business Oriented Language. Where Fortran was used for scientific computing, COBOL was developed to be used for business computing. The original COBOL specification was created by a committee of researchers from private industry, universities, and government during the second half of 1959. COBOL specifications were to a great extent inspired by the Flowmatic computer programming language. Flowmatic was invented by Grace Hopper. Grace Hopper is known as the mother of the COBOL computer programming language. She is also known as the first COBOL computer programmer. The first compilers for COBOL were implemented in 1960. This essentially allowed the same COBOL computer program to run on different computer manufacturers' computers. RCA and Remington Rand Univac were the first computer manufacturers to demonstrate computer hardware compatibility. After 1959, COBOL underwent several modifications and improvements. As the improvements were made, incompatibility issues between different versions of COBOL were addressed. The American National Standards Institute developed a standard form of the computer programming language in 1968. This version was known as American National Standard COBOL. In 2002, American National Standard was upgraded to support the computer programming language object-oriented paradigm. As such, the COBOL computer programming language persists throughout the world today. This wide reach has extended to both the public and private sectors alike. Today, COBOL computer programs run under a wide variety of operating systems and computer hardware platforms, namely IBM Z and ZVSE and the POSIX families. In fact, in 1997, the Gartner Group reported that 80% of the world's business systems ran on COBOL, with over 200 billion lines of code in existence, with an estimated 5 billion lines of new code developed annually. My first computer application for a natural gas distribution utility was written primarily in COBOL for an IBM 360 computer. I also remember attending an Association of Systems Managers meeting in Hartford, Connecticut, addressed by Grace Hopper in the mid-1970s. She stressed the requirement for having multiple computers working in tandem to solve some of the world's greatest problems. She stressed the point that one single supercomputer, regardless of exponential advances in information technology, would not provide enough computer processing power. She certainly was not only a pioneer regarding the evolution of computer programming languages, but moreover the role of computer programming languages played, particularly their impact on the discipline of computer science. I often wonder what she would think of today's cloud computing architecture. RPG is a high-level computer programming language used to develop business applications by computer programmers with limited expertise. RPG, or better known as Report Program Generator, was developed by IBM in 1959. Originally, RPG was used as a tool to replicate punch card processing on the IBM 1401. The original RPG was updated to RPG-2 for the IBM System 3 in the late 1960s. As such, RPG-2 evolved into a high-level computer programming language equivalent to COBOL and PL1, two computer programming languages that continue to be supported by IBM today. Consequently, RPG became a popular computer programming language for IBM's mid-range computer platforms. For example, the AS400 series, where RPG-4 provides a modern computer programming environment. An RPG program typically starts off with file specifications, listing all files being written to, read from, or updated. Next, followed by data definition specifications containing computer program elements, such as data structures. The data definition specifications are followed by calculation specifications. Calculation specifications contain the instructions that operate on the data. Output specifications follow, specifying file output and reports. This set sequence of specifications was known as the computer program cycle. Thus, every RPG computer program executes within an implied loop or computer program cycle, where the execution of the computer program cycle is controlled by the computer program specifications provided by the punch cards. Today, most RPG computer programmers avoid using the computer program cycle, but rather favor controlling computer program processing by using structured programming best practices based on a set of accepted structured programming control structures. As such, today, RPG is considered a dead computer programming language.